Hello, my name is Peter Schott. Today I'll be demonstrating the program CBFer for the automated calculation of ciliary beat frequency. To begin, we must first load a movie containing our sample data. It will just take a few seconds, and the movie's loaded. On the left we have the number of frames, its resolution, the length in seconds, the file name, the currently playing frame rate, and a list for the regions of interest and their individual details, which are both empty because we haven't created any regions of interest yet. Now on the right we have the main window, which plays the movie on a loop. At the bottom we've got a bunch of different media controls. We can pause, move forward frame by frame, backwards, by blocks, etc. We can also use the scroll bar as a kind of means to track to different areas of the movie. And also, if we change the number here, we can control how fast the movie plays. So say we set it to 20 frames per second and play it back. It's visibly slower. If we want to reset it back to the normal, just leave it empty, click OK, and it goes back to the base frame rate which was in the file. Now, creating regions of interest is very simple. Just clicking anywhere on the movie canvas will create a region of interest. It will appear in this box to the left, and when you select an individual one, it'll show you what position it is, its size, and the calculated frequency. So you can see that this one here associates with this box right here. We can delete it by right-clicking, or we can use this option here to just clear them all at once. Now, let's move on to whole image analysis. So by selecting this option here, we now begin the calculations. What this does is divide the image into 4x4 pixel regions, so the entire image into those little ROI squares basically, and performs the same signal processing step on that to calculate the frequency. And this will bring up a frequency histogram in a moment, which is unique based on the sample. Now, what we see here is a primary peak at low frequency from 0 to 5 Hz, and then another peak from 11 to 14 Hz. Now, this part here corresponds to the background of the image, which is basically this region. And this peak here corresponds to the cell, which is pretty much any area inside here. It'll be relatively high frequency. Now, we can also export this image and save it straight to disk, which makes it useful for analysis later on. Now, also, we can generate a heat map, and this shows the frequency distribution across the image. So it makes it a lot easier to see areas which have high frequency versus low frequency. Now, this is a black to white scale, continuous, from 0 to 14.87 Hz, where the black represents the lowest and white represents the highest. We can query individual bits of this image to see what the frequency is at the point where we click, and we can change the coloring from black to white to black to red, if that is preferable. So going back for a second, we can also export this image to a file. It's saved, and we can move on. And that concludes our demonstration of the CBFer program. Thank you.